Okay, so continuing where we left off, I wanted to give you a little bit more information about the weighted mean. We began this problem in class and we talked about the fact that weights are percentages or frequencies, any values that cause one data value to count more than another. And so we talked a little bit about how this formula would work. A tip I want to give you here when you're trying to do a weighted mean is to set up two columns where in one column you list your individual data values. Those are the things that you actually want to average. And then you list your corresponding weights just to make sure that you keep everything straight when you go to plug into the weighted mean formula. So if I were going to do that here, my data values, and again, those are the things that I'm looking to average. So notice we're trying to find the mean account balance. So that means my data values are going to be these different account balances that I'm given of 759, 1985, 1410, and 348. And my weights are going to be, in this case, the frequency for each one of those. How many days did this occur? So 759, that occurred 15 times. 1985 and 1410, those both occurred on 5 days. And 348 on 6. So when I go to calculate my weighted mean, right, you see my formula up here. It says take the sum of the data values multiplied by their weights. So what that means is I want to come over here and I want to take each value and I want to multiply it times its weight. And then I want to add those values up. All right, so let's go ahead and do that for each one. If I take 759, multiply by its weight, I'm looking at 11,385. Take 1985, multiply by its weight of 5. Same thing with 1410. And then lastly, 348 times its weight of 6. And once I have those, again, what I want to do is add those up. And in this case, that's going to give me a value of 30,448. Now, that value is this value in my numerator. Because again, I took each value, I multiplied by its weight, and then I added everything up, which means I took the sum. Now, in my weighted mean formula, you'll notice we want to take that and divide it by the sum of just the weight. And this is why I like to do the X column and the weight column, because it ensures that you add up the right values when you go to get this denominator. So what I want to do here is I want to add up only the weight column. All right, 15 plus 5 is 20, plus 5 is 25, plus 6 is 31. And that is what I need to divide by here to get the correct weighted mean. Okay, so I can't divide by 4 because there are 4 values, right? I have to divide by the total weight because, again, that's what tells me, in this case, the total number of days. It makes more sense to say, you know, there's 31 days in May than just 4 different values. So if I divide that by the sum of the weights, which is 31 here, then that gives me a correct weighted mean of $982.19. And so it's going to work that way anytime you have values with differing weights. And like I said, many times those are frequencies. How many times did this occur? It's very common to see percentages. This counts 20%. This counts 30%. Another very common use of the weighted mean is when you're asked to find the mean of a frequency distribution. Now, we already know that frequencies are weights. We just talked about that here with our account balances. So if you're looking at a frequency distribution, classes and frequency, the main thing you have to remember is that in that case, the X values are the midpoints of the classes. All right, so let's look at just one here. I pulled this from your practice homework in section 2.3. You've got this frequency distribution that's given, classes and frequency, and you're asked to find the mean of the frequency distribution. So the only way I can do that is by the use of a weighted mean, because frequencies, again, those are weights on the individual values. So what I would need to do here, first thing, is I would need to determine, remember if we're going to use a weighted mean, I need to determine what are my x's and what are my weights. Now again, for a frequency distribution, what you have to remember is that the x's are the midpoints, and then again, we know that frequencies are always weights. So I want to convert each class to its midpoint, and remember how we do that. We add the limits together, so first class 28 and 32, and we divide by 2 to find the midpoint. So I'm going to go through each class here, and I'm going to convert to the midpoint, and that's what I'm going to use to calculate the mean of this frequency distribution. All right, so I'm going to be looking at a midpoint of 30. I'm going to be looking at a midpoint of 35, of 40, and of 45. And those are the values that I'm going to use to represent each class. All right, so that's going to be my x's here, my midpoints. And I'm going to weight each of those midpoints by the frequency. All right, and then we remember our weighted mean formula, what it looks like. We take each x, in this case midpoint, multiply by its weight, which is frequency, add those up, and divide by the sum of the weights. All right, so just like we did on our previous example, I'm going to go through and multiply each midpoint times its weight. I'm going to report those in a column over here. And then to get the sum, I'm going to add those values up. Now again, that sum is this value in my numerator, right? Because we took the midpoints, we multiplied by the weight, and then we added everything up, and we got 1,035. Now, I need to divide this by the sum of the weights. And so again, this is where you want to be careful. When you divide, you don't want to divide by four classes, right? That's not going to tell me anything. I want to divide by the sum of the weights, and the weights are these frequencies right here. So if I look at adding up my weights here, I've got a total weight of 29. That's what I need to divide by here to get the correct mean of this frequency distribution. So if I do that, I get a mean value, and let's see, this says round to 1 decimal place, so I get a mean value of 35.7. We're looking at gas mileage here, so we're looking at 35.7 miles per gallon as our mean of this frequency distribution. Remember what I told you in class about frequencies? Do not ever be tempted to add up your frequencies and divide by the number of values. There will never be a place where you do that. So just remember, for quantitative, for numerical data, frequencies will always be used as weights, and that'll tell you to use this weighted mean formula. For qualitative data, non-numerical labels and categories, all you will use the frequency to do is look for the one that occurs the most often and classify that as your mode. All right, so here again, I've calculated the mean of my frequency distribution using midpoints as data values and frequencies as weights, and I report my mean here at 35.7.